Hello everyone, this is Nishant Malhotra from the Middle Road, a global thought leader and online learning platform. Today I'm going to be talking with Bhargav Sri Prakash, and it's great to have you here for a podcast with the Middle Road. Bhargav, welcome to the Middle Road platform.
Thank you, Nishant. Thanks so much for having me here.
Okay, just let me give a very brief introduction to Bhargav. Bhargav is an alum of University of Michigan and Arbor, and he's a fellow alum from University of Michigan, and he's passionate about using technology to solve complex problems governing the society. Now, he's a recipient of the world's first digital vaccine patent. So this is very exciting. And this is what we are going to be talking. We'll talk a lot about this particular aspect today. He's the founder and CEO of Friendslearn, our biotech and medical technology company, and pioneer of neuropsychology-based digital vaccines to prevent lifestyle diseases. He has worked in collaborative roles in research with leading global research and think tank institutes. And I think, Bhargav, this is where, you could also talk about your work with various leading, institutes like Carnegie Mellon. You also with John Hopkins, you have done something. So it'll be great as we progress, you can talk about it.
Sure, absolutely. We're delighted to do that.
Thanks once again for joining the Middle Road for a very informative conversation with regards to your work at Friendslearn. Let's start with Bhargav. Bhargav, you've received the patent for the world's first digital vaccine. Now, that is something very innovative and very fancy. Now, the digital vaccine uses technology to nudge people towards positive behavior using a tool called neurocognitive training. Tell the audience about this wonderful invention. And then as we go forward, we'll talk about all your rules.
Thank you. Thank you, Nishant. Again, real pleasure and honor to be here. Digital vaccines is an area that we've actually been researching for almost 12 years. And as you mentioned, Nishant, it's been a product of fundamental scientific breakthroughs in neuroscience and an area of being able to stimulate the brain and the gut axis. Our focus has always been on children. And the idea of the science was always to think of what was the future of vaccines going to be. This journey over the last 12 years as an engineer coming to a problem or trying to solve a problem in medicine or in public health has I gained a lot of inspiration, I guess, from the University of Michigan School of Public Health, which is the home of the polio vaccine and the home to Jonas Salk's work. And for us, it was always using that as kind of our North Star to think about the future of technology, all these frontier technologies. Whether it was artificial intelligence or machine learning or deep learning or neural networks or even virtual reality technology, and really thinking of how these emerging frontiers of technology will have a bearing or a potential bearing in the prevention of disease. Vaccines, I always felt was like, the bright spot in medicine because of its role in eliminating diseases like polio, which, India is a huge beneficiary, as is the world from eliminating or eradicating smallpox. So we wanted to think of how new technologies could eradicate diseases of the current, whether it is diabetes and heart disease and cancer and hypertension, cardiovascular disease, and even cognitive disease, mental health, overall thinking of how even now we can reduce infectious disease incidence and risk through technology. So neural networks are an exciting area, I guess, and vaccines have also been a very exciting area given the last 2 years that we're living through and emerging from. But the idea of a new kind of a paradigm for vaccines to non-invasively prevent disease using technology with the underlying science of vaccine development and validation and safety and ethics and efficacy and effectiveness was kind of the bedrock. But we've been able to achieve all of this because of a project or a center at Carnegie Mellon, which is really the lead on this initiative, where I serve as a partner for research, translation, and innovation. And it's been a multi-institutional collaboration. So we actually collaborate with the University of Michigan School of Public Health researchers from there, Professor Rahul Lodania, who's a young kind of a rock star at the University of Michigan School of Public Health, and also with Johns Hopkins University at the Bloomberg School of Public Health, Baylor College of Medicine, Kansas Medical Center, University of Pittsburgh Children's Hospital, Stanford School of Medicine, and the University of Oxford, and a growing NUS, National University of Singapore, and a growing kind of an ecosystem to really validate the science, to develop the science, and to even present humanity the option to prevent disease through all these frontier technologies, which is what digital vaccines is and aims to be even more so.
But there are two questions which come up. One about neural networks you're talking about, and I think that's a very, very poignant topic because it's a major thing in machine learning. And very good that you talked about also University of Pittsburgh, because Carnegie Mellon and University of Pittsburgh, they're very close to each other, and Pittsburgh is a fantastic place in the US. When you talked about, that is something which I had in mind. You talked about your work as a part of Carnegie Mellon University. That's where the digital vaccine project is going on, right? That's where it all began. Richard King Mellon Foundation awarded the grant for the digital vaccine project. You shared the journey that brought you to Carnegie Mellon University project. Now, how did it just sort of go about?
That's a great question. So, this Carnegie Mellon and Professor Rema Padman, who leads the effort and the lead researcher at Carnegie Mellon, is a trustees professor, and she shares a joint appointment also with the University of Pittsburgh Medical Center, School of Medicine there. And she's a bioinformatics expert, really the world's kind of renowned, foremost researchers at the intersection of data science and clinical outcomes and medicine. And she's been kind of a pillar for this whole idea, the evolution of digital vaccines, and as have several of our colleagues and fellow faculty members at Carnegie Mellon. But we kind of, the early pieces, even before we started collaborating with Carnegie Mellon, which has been a collaboration going for almost 8 years, coming up to a decade soon. But we started working on this idea with when I was a fellow. I had an invitation from the Kauffman Foundation in Kansas City, and I was spending time in Kansas City, and through the foundation actually got to be introduced to an eminent, really brilliant neuroscientist working at Kansas Medical Center. Her name is Amanda Bruce, and she's done some of the world's first fMRI-related work on children, analyzing neural response and understanding from a neural response perspective, and also from a neural makeup perspective, what could be predictive of whether a child would be pre-diabetic or on the obese end of the spectrum. And through our work with her, we kind of developed some ideas around neurocognitive training. The idea that we could use neuroplasticity, we could use virtual reality technology powered by this neural network. So it could dynamically almost signal and message the brain and induce these physiological changes that lead to downstream, health benefits, and that could be measured and could be quantified. And we were able to do this with non-invasively. So the other big breakthrough with virtual reality technology was that we could almost in a very targeted and a deliberate way increase blood flow to parts of the brain, increase responsiveness to certain parts of the brain, and almost unleash these self-healing mechanisms for the entire body. And these were really at a biomarker level along the brain and the gut axis. So really the pathway linking the brain and this feedback loop between the brain and the gut. And then from there is kind of the core to the human body and our existence, really being able to reach the immune system. So along with that, using virtual reality and gamification powered by this neural network, we're actually able to almost read and write at a biomarker level to biology and lower the risk of a whole vast kind of an expanding spectrum of diseases. So that's how it all came about. The first trials were run at Baylor College of Medicine, the first human trials. So after we worked with, the early ideas, we subject this to the same lens of vaccine development. So going from, animal models to theory, and then, human trials. And we worked with Baylor. They ran the first 2 randomized controlled trials in children. And the findings were really spectacular because we were able to affect what is called neurobehavior transference, which means we could stimulate the brain using virtual reality and gamified virtual reality, but that was transferring over to health outcomes. And we could show this through a randomized controlled, blinded trial. And so that breakthrough was published in Obesity Week. And then we then partnered with more researchers at Kaiser Permanente and the University of Houston. And then it led to this remarkable partnership with Carnegie Mellon and Johns Hopkins and Stanford and a whole host of scientists across our ecosystem that are breathing life into this idea of digital vaccines.
You actually very good. You talked about randomized controlled trials. For my audience, let me explain because they might, and you can correct me. Basically, in a randomized, this was for how long?
So the randomized controlled trial the first trials that we ran were with children and looking at immediate effect. So they would get an exposure to this intervention or this therapy. And then we would actually see these children almost immediately responding and starting to make healthy choices as they go through the cafeteria. The next set of trials...
Just to sort of also let, because people might not be knowing, in a randomized control trials, there are 2 groups. One is given the intervention, the other group is not given the intervention. And then you look how, so it gives you very good, what is known as effect between what happens in counterfactual. If you could look at the impact evaluation module on the middle road, which is part of the subscription model, you'll come to know a lot about it. When you talked, it's a double-blind experiment. Was it a double-blind?
Yeah.
The participant or the other person they're not aware of who each other is. Am I correct here?
That's right.
Yeah. So this is a very good way of doing what is the impact of the intervention. Yeah. So carry on.
Yeah. So that's the gold standard in medicine to establish causality, right? So we want to make sure that we can compare between groups so that it has some statistical significance across a sample, and we want to ensure that the intervention is the only significant variable between the arm of the trial that gets the intervention versus the placebo or the control arm. And the differences are documented, measured through observation, and the observers are blinded to whether the people that they're observing belong to the treatment or control. So these are scientific methods by which they establish a rigorous process and a protocol to establish causality and to determine whether it's statistically significant, and you can establish that it is actually the outcomes that you're seeing are produced by the intervention, and what is the effect size, and how does that affect the sample. So that was kind of the lens. Again, it has really been perfected in the biomedical world, but it is kind of accepted as the world's gold standard in kind of this type of science. And so we held
in the development world. I mean, it's now a gold standard of measuring the impact. You're right. It started from the medical world, and RCTs now have become a standard. Now, a lot of people, even in the development sector, whatever interventions they do, they prefer that. If it's usually between 1 to long term, right?
Absolutely. The whole kind of evolution of this idea has been subject to several randomized control trials, and then the early trials at Baylor set the stage for us to do more longitudinal trials. So they were children who were tracked for several weeks at a time, and in multiple sites, and so that allowed us to get various populations and have a consistent way to measure whether the intervention was working in different settings, different geographies, and that also
all over US or also Singapore, you said. So it was at different countries and also locations, right?
Yeah. So the second set of trials was run all over the US.
Okay.
And that was also reported in journals and presented at medical conferences. And then we kind of branched from there onwards to kind of think of this more globally. And so we've run trials with Johns Hopkins in India, with the National University of Singapore in Singapore. We've also run trials in Botswana. So really kind of thinking of digital vaccines having applicability and generalizability for global health and populations around the world. So part of our mission is to think of solving this problem as a citizen of the world, and it is clearly health is a need across the entire globe. So technology has the potential to scale and also be mapped with these precision methods enabled through a neural network, so that it's relevant to that one individual. So it doesn't necessarily fall into like this one size fits all approach. There is at least an ability to personalize it and make it relevant for that one individual.
Well, I really want to congratulate you. It's a fantastic achievement. First, it's, something which you have done is very uncommon. And I know the neuroscience is like sort of coming up. What's so great about it? It was done at a lot of places. You talked about NUS. So did my exchange at Nagnan Business School. And Singapore is also a wonderful place, a fantastic place to be there. What's so great about it? It's very universal. It's been done. You did it in Africa. You did it in India, Singapore, in Asia, Africa, and then, of course, also in the US. It's I would say, a remarkable achievement. And I want to congratulate you and the whole team. And it was very scientifically done. And talk about these results. One is like you also your organization does a lot of exercises or games. You have gamification you talked about, where you modulate the behavior of children through games, and then you have neurocognitive training also. So it's much more easier to do it for children, but it's not. How effective is it when you are talking about same effect of vaccines on adults?
No, that's a great question. And so, the power of our platform is really the fact that at the core of it, it's based on neuroplasticity. And neuroplasticity actually is available as a mechanism throughout the age spectrum. Our focus in terms of pediatric population is kind of was strategic, but also the best time, I think the most fertile kind of time to intervene and establish healthy habits during the formation stage of life, rather than trying to fix things after things have either been set as you progress into adulthood. But that said, we are already considering and expanding the scope of our platform to cater to adults, and since our entire platform is built on neurocognitive outcomes and modulation, we certainly can expand this to areas of neurocognitive disease and neurocognitive degeneration, and that's a vast opportunity. But this is really kind of, I guess, at the platform level. It's exciting because there's so many different applications, but we've, I guess, chosen to stay focused on a pediatric population for the time being, but with the idea to be able to expand to cater to across the entire spectrum.
So let me ask you, a question which always comes to my mind. Now, whenever I talk to you, this is a project which is done at a very grand level. There are so many actors involved. and so in different kind of actors. So it's a collaborative project. How difficult was it? What are the positives and the negatives? Was it very difficult to sort of, be on the same platform, have that common goal, which you usually, you mark out with a theory of change, you go on the outcome and then sort of map it back? Was it done that way, or how was it? Just talk about whatever your experience here, both the positives and the negatives.
No, it's been a remarkable journey. I think there is no doubt that this wouldn't be what it is today without like the collaboration with incredible scientists and incredible uh, collaborators, engineers, science, researchers, fundamental science researchers, outcomes researchers, and then even bioethics experts. And what's remarkable about this, and I think in the journey, I think it grew very organically and very naturally. I think I wish I could take. I would be misleading anybody to think if I said that we kind of had a grand design, but these things all fell into place. I think there was obviously a thread and a desire and a vision or a mission, and it drew people who were naturally inclined. And I think everybody was intellectually stimulated by the scale of the problem, and trying to find a solution to something like this was obviously something hadn't been attempted before. So there's a certain challenge or complexity that drew people who are not afraid of complexity. And it also was a filter. So the people who didn't have an appetite for complexity or didn't have an appetite for science automatically self-selected not to be a part of this so far. But I think, as this broadens and deepens, I think there are at different stages as this evolves, different skill sets are required, and different groups of people with different types of thinking required to scale this, to sustain it, and to really deliver impact. It was challenging. There's no, I would be intellectually challenging, emotionally challenging, spiritually challenging. But I think what kept us focused and kind of resisted the temptation to give up was kind of this underlying, I guess, mission that we ought to try to make the world a better place for our future generations, and that health is incredibly important, and that without health, no wealth matters. And then I think my personal journey also reinforced that. I saw it with my late father in his final years. My youngest daughter, who inspired me to start thinking about this, was actually also struggling with a lot of foodborne allergies and asthma, mostly as a result of stuff in the diet and nutrition. So these were all reminders and reinforced that this was an important problem and that it had to be solved, and the whole world was facing it, and there wasn't really enough going towards trying to solve this. So I guess a sense of duty, a sense of adventure, an engineer's mindset to try to come up with a solution for a very complicated problem is what has allowed it to build itself. But it's still, we're 12 years into this, Nishant, but it feels like we're just getting started.
Must be a fantastic feeling, after 12 years, you got a patent, things all rolling out, right? I mean, the vaccine is available in the US now digitally.
Yes.
Comes through an app? Okay.
Yes. So we're available, in around the world, but in the US and also in India, we're kind of scaling this, to serve children in schools. So there is an accreditation program, or I would say kind of like an accreditation program for a DVX school. So it's a recognized school partner that can get access to this technology and make it available to children. So there are all these new innovative ways to even bring something as innovative as a digital vaccine, it doesn't have to flow through the traditional channels of a vaccine. And that, I guess, brings with it, the added X factor in terms of how disruptive it can be, because unlike traditional biologic vaccines, we're not manufacturing it. There's no distribution. There's no cold storage. There's no shelf life. We're able to kind of go anywhere there's a smartphone with an internet connection and be delivered in an appropriate, precise way to be able to protect the health of that one individual. So there's tremendous potential as digital technologies are in the hands and kind of addressing inequities in health and in education. Technology can sometimes play a leveling factor and make, hopefully, we envision that health should not be a privilege for the elite or for those who can afford it, but it should be accessible, and this kind of a technology should address some of the underlying health inequities in our society.
Wonderfully put. I do agree that technology is totally leveler, and there are a lot of ways we can put this vaccine across the world, whether it's a low-income country or a very advanced country. There is a lot of effective ways to, almost everybody has, or there are ways you can put across a smartphone and get, or people, get the final product to the people. And I think that's a very good idea. And let's hope so that the whole world is able to achieve. Of course, smartphone is not with everybody, but there are ways where you can subsidize it, or there could be a place where people could go, with a common phone, and they could use it even in rural areas. Something like that could be done by the government.
Exactly. So it feels, when we started working on this, Nishant, honestly, when we were thinking that, we would choose to develop this evidence base, because it was a huge investment of, effort and time and resources. But we chose smartphone platform. And honestly, when we were getting this approved for our very first trials, and the questions come up because ethics experts question whether this would address the inequity, and whether this technology would be just restricted to solving the problems of the very wealthy who could afford a smartphone or an iPhone or a high-end Android phone. And this is going back to 2011, right? Yeah. But we bet, and it was a bold bet, and I'm so glad that we were kind of right, because if we were wrong about that, then anything we did would have looked very different. But the building blocks, you had to get that right, because the cost of failure, as we were at that early stage, there was really no room to fail. We had to be right about the big decisions. And so we were lucky in some ways that, smartphone penetration and internet penetration has really kind of made technology accessible in a country like in India. You see how, almost the bottom of the pyramid has access to smartphone technology, and therefore data, and therefore a digital vaccine. So even places which may otherwise be remote to get to from a public health perspective, smartphone technology and internet connection is reaching those nooks and corners of this complex, diverse country. So I think it's certainly a promising way to think of of creating a solution that can scale at India scale, and therefore be better suited for global scale.
Well, I think it's a brilliant decision, and like GV says, brilliance. It's come out like absolutely. You look at the time, and you are absolutely right. A fantastic question, and this is something I think the whole world would like to know. For example, when you have Carl Sunstein and Richard Taylor. Richard Taylor, of course, won the Nobel Prize in economics. They have written a lot about nudging and how nudging can be used for public good or for societal good, in public policies. Yes. Now, although nudging can have a productive behavior, we have also seen Facebook has come under a lot of criticism or is adverse cognitive policies on Facebook customers. And, you had also a documentary on this particular subject. Just to sort of know your views, because you're come across as an expert who's been dealing in this field. How do you think the cognitive field is going to evolve for the better as we advance? We're looking just at the, how because public perception is very divided, I feel. I mean, there are positives and negatives.
Yeah, no, this is such an important question, and something that we've had to consider from the very beginning. And again, the reason why we had to go very deep into these kind of topics and really flush these ideas out and determine what we were going to do and make sure that from an ethical perspective, we were on the straight and narrow, on the middle road, was that the fact that we were catering to children from a medical perspective are considered a vulnerable population. So children, it's the highest bar in terms of being able to get data or to use children as part of any human subject research. And the reason is obvious, because children cannot fully understand the risks and so they cannot be unscrupulously used for any outcome. And there's an elaborate process of parental consent and informed assent. And if a child were to even be remotely uncomfortable at any point, then they could just withdraw, right? So you can't even nudge them or encourage them or incentivize them to continue. So that meant that we had to really think about the platform, the technology, the use, and a lot of questions we had to field from ethicists, bioethics experts, was around the choice of our technology, and that often technology itself is the culprit for a lot of health issues. Least of which is that it promotes a sedentary lifestyle. But on top of that, questions of all that people read and is established around social networks very aggressively trying to use these methods and perfect these methods and really refine and hone these methods to kind of drive engagement. So the one thing we helped people understand is that our business model is not advertising supported. So we made a very conscious choice that we would not generate any revenue, not at that time, but even in the future, out of advertising. So nothing linked to additional screen time. Now, often the understanding between the use case of a technology and the technology is fairly nuanced, as you can appreciate. You can't say we're not going to use planes because planes were used in a terrible way during 9/11. But you can't say we won't use smartphones or apps because there are some apps that are very aggressive in the way they engage and that they really create an addiction, which is not good for health. But it was really about the content. It was really about the approach. It was about kind of the guardrails that we established for ourselves from an ethics perspective. And we hold ourselves accountable to the highest standards. So we kind of invested heavily in not just thinking about it ourselves, but subjecting this to external scrutiny. And that is part of the scientific process. So for better or for worse, we decided that if we wanted to deliver the impact at the scale, even though it was going to delay things, we were going to go very deeply into science and the scientific process out of respect, but also believe that that's the way to create something truly sustainable to tackle, the scale of the problem that we were facing. And I think that holds us in great stead now, because we've flushed out these questions and try to design a solution where recognizing that screen time or too much screen time has its own complications. So an ethics committee would say, what about the radiation? What about the bright light? What about, screen time? About the sedentary behavior? And so we've designed the application, and the dose is only 30 minutes a week So it's not like we're trying to max the amount of time that the child has to play. There's no incentive for us to do that, because our sole purpose for existing is to protect the health of the child. So recognizing that what we're using could become toxic if overused, and that's very understandable in medicine, because there are toxicity studies, and if you introduce an agent beyond a certain threshold, the same chemotherapy agent could kill you, right? But if in the right dose, at the right quantity, at the right time, in the right location, then it could potentially, cure or reduce cancer. So that's well understood from a medical perspective. But doing what we did through that biomedical lens with the highest bar of science and ethics is the reason why we have said we would be a digital vaccine. So it would meet that bar, meet the entire kind of checklist that a vaccine is subject to, which is the highest bar in medical science, because you're giving it to all healthy individuals. So it's very important to make sure that we know the risks, we know the side effects, we know the efficacy, the effectiveness, and obviously the ethics of it. So that's all that we bring to bear as we think about these frontier technologies. It was about thinking of what digital vaccines would represent to humanity as the future of vaccines.
No, okay, so that was a very vivid description. How do you think, of course you answered a lot of things, but how has been the response in the scientific community? It's been very positive, right? I mean, they have come out and it's been you think sort of a game-changing experience?
Yeah, no, I mean we bring to bear like this ecosystem now, so there's multiple researchers across multiple institutions really getting behind the idea and challenging the idea, looking at it from various perspectives. It's also interdisciplinary. So, we have data scientists, and we have clinicians, we have physicians, we have endocrinologists, we have neuroscientists. So everybody looks at it from their vantage point or their position of expertise. And that's what builds a very elegant solution. You're trying to thread the needle or multiple needles as they're moving through space and time, and you're trying to come up with one solution that will hit the target. And so far we've been able to synthesize all this disparate, siloed kind of expertise and this thinking into software on a mobile device delivered in this way, in a scalable way. And so yeah, we have, I think one of our strengths is kind of the conviction and the richness of our ecosystem of scientists. So what we need beyond the science is the additional kind of ecosystem to kind of scale this and take this, address it from a policy perspective, address it from a scale implementation perspective, from a outreach, and there's still lots of issues we need to take it from the science into translating that and getting it to impact billions around the world.
Before I come to the last question, this is something, this is also a bit of a personal question. I just want to check what drove you towards this. This is a very esoteric topic. I mean, much more esoteric when it was about 12 years back, when you started on this journey. And you did, of course, your master's in engineering from University of Michigan. So being that ground, what propelled you to come to this field? I mean, what was the sort of magic, the mojo which brought you in this particular direction?
No, it's, I think,
different fields, right? I mean, from engineering background and particularly what you did.
No, I'm constantly amazed. I never cease to be amazed, in terms of the journey and the adventure and all you're looking back at all the dots that you can try to connect. As you're looking forward, or when you're in it also, sometimes it's really hard to understand what's going on. But I think, life's journey, I came to Michigan as an engineer to study engineering. And I actually studied to specialize. My research was all in computational fluid dynamics and thermodynamics. And it's the lens through which I see the world, and I try to understand the world. And it's fascinating because it's fundamental physics and fundamental chemistry and fundamental maths, and and those are all the building blocks of everything from how matter moves and transforms and energy transfers and how the brain works and how neural response can actually map in a very in a pattern, and how do you understand these patterns, and then how do we react as society, how do we react as individuals. There's a lot of similarity. It's incredible how there is a similarity in patterns across the cosmos, whether it's biology or atoms. And so that ability to kind of see that and apply the same thinking, I think the Michigan education, the foundation that we got to break it down from first principles and then build from there, I think is what I still rely on to come up with a solution. But I think life's experiences, I came to Michigan and then serendipitously started life as an entrepreneur. Had an exit in my fairly early in my career. Sold the company and started another company in the virtual reality space, a lot to do with the University of Michigan in education. And that company also got sold. Then I spent some time investing. But this was a wake-up call for me after becoming a father and getting to see the world through my first daughter's eyes. And America, as you know, Nishant, when we all moved there as a grad student, America is the land of processed food. It's the land of breakfast cereal. It's amazing to go to Kroger and see as far as the eye can see an aisle full of options. And then it's also the land of hyper-targeted, highly sophisticated advertising. And I got to see through my daughter's eyes before she could speak how she could use technology, how ads were reaching her, how she was reacting to ads, and how she developed a taste or a preference for star cinnamon cereal or high fructose corn syrup in different shapes and forms, and how that affected her health because she had foodborne allergies and she developed asthma. And so that's when I realized that this is a case of we've lost the plot, right? Like we're literally planting the seeds of sickness even before a child can speak. And those were the seeds of diabetes and heart disease and hypertension, cancer, probably risk for COVID or influenza, ADHD. I mean, the list is massive. And so I kind of said, well, this is crazy. This is a case of capitalism that's really gone mad, where we're compromising our next generation, let alone our own generation, and nobody's really paying attention to health. There's a lot of profit from sickness, and not so much of a focus on prevention. And so that was the motivation to try and solve the problem as an engineer. Life's journey, seeing this, in personal ways, how it impacted, me, my family, members in my family, my late father. I realized that this is a very, very significant problem. I think the greatest problem that we face as humanity, and planetary health depends on the health of the individual, and the health of the individual depends on planetary health, and they're all interconnected. And at the root of it is, all these things that we choose to do. So if we can, hopefully build a better world than we found it, and do it with technology and do it sustainably, then I think our vision would be realized.
The good part, when you talk about America, there's a lot of work which is being done, this very scientific community, to come out of the things. So whenever we talk about America, it's like land of opportunities. I think a lot of very classy people, the way they speak. But what good part is, there's a lot of work being done to rectify some of the things which you talked about, and that's amazing. We come to the last question. It's always been the question about what's your aha moment. Do share. I mean, if you have more than one, you can share as many as you want about, the aha moments, specifically when you're related to the digital vaccine project, which you did over a period of years.
Yeah, so the aha moment was really when I think we did our first, trials and to get a sense of what was going to be possible. We've been thinking about all these technologies, right? Smartphones, virtual reality, AI, or I guess AI or neural networks. Before, I guess they got really exciting, and now, of course, it's considered a frontier or a hot area. And then now, of course, there's metaverse. But we were really hoping that we could use all these technologies and deliver good, which was our intention, and protect health and prevent disease or lower the risk of disease in a very scientific way. But I think when we the first aha moment was when we thought that there was this convergence between technology and medicine. So I was a technologist, an engineer, and I realized that my passion or my calling began to be about health and the health of society and health of individuals, to empower them with health. Then I realized that, technology and medicine were going to intersect, and it was going to happen. It could no longer be, our health could no longer be managed or treated just with, pharmaceuticals or pills or biochemistry. There's so much opportunity to be able to impact our health in other ways. Technology, that was an aha moment, the idea that technology and medicine was going to converge, technology and vaccines would converge. And we were right. We were very lucky because that trend is also played itself out, as has, smartphone penetration, as has virtual reality technology and metaverse, as has neural networks, and the fact that all these things could be brought to bear via these smartphone devices at individual scale. I guess a series of aha moments, but the big decisions that we made could have taken us on a completely different direction. But now we are really at the intersection of so many massive trends, technology and medicine, or digital medicine, digital vaccines, virtual reality, metaverse technology, AI, neural networks, mobile technology or smartphone technology, public health or vaccine technology, right? Like, we would have never imagined that vaccines would have played the role that they have in the last 2 years. Nor would we have ever imagined that we would live through a pandemic, as we are still emerging from it. Yes, thinking of the future of vaccines, it's more relevant now than ever because of what we're living through. So a series of aha moments, and I think it all kind of builds on itself. And I guess we'll never know, which is the real aha moment. When we look back, it feels like there were so many small kind of, incremental steps and lots of missteps along the way, but lots of, things that got us to this point. So yeah, that I guess is the journey.
Thank you. It was a fantastic, conversation. Just to add up on a couple of things, I talked about GVs. So whenever I'm talking about GVs, it's actually ending to PG Woodhouse. It was a fantastic author. I'm sure you played a great role in our series.
Of course.
But, like you said, the technology and medicine is like converging. It's blended. And that is truly so fantastic in what you have done. We've always seen that medical, of course, technology could have enabled a lot of things to be, delivered. But this is the first time we are seeing that technology is judiciously sort of coming and blending holistic effects through like a medicine, using the technology or, the neuroscience which you talked about. I think that is something which is very innovative. It's very pioneering. I mean, this is something which you don't hear of very often. And this is also like a very fantastic example of using nudging, and you can sort of have a discernible, you have an impact which is very measurable for the people, and it just come out at extremely, the time when we have seen, like you correctly mentioned, the pandemic. Nobody had even ever thought that you would live through something which you have lived. It's just something which would live for an experience which is like the Black Swan event, which you say.
Totally.
Thanks a lot, Bhargav, for coming, for joining, giving me time. It's been always a pleasure to meet you. It's very glad that I was able to, finally connect and we could have a conversation on your wonderful work. I really wish work goes up, scales up globally. And I wish you the very best in what you're doing.
Thank you, Nishant. It's a privilege and a great honor is mine. So thank you for this opportunity, and looking forward to many more chances for our paths to connect and intersect.
I'm sure, and there'll be a lot of chances. Of course, we'll keep in touch. Thank you. I really appreciate. Welcome and thanks again. A big thanks for coming and talking about your work.
Thank you. Thanks again. Thanks for having me. Bye-bye.